Hello everyone, Mr. Hames here. Hope you had a nice Thanksgiving/fall break. Today we're going to do a hot and cold pack lab. So if you're not here, if you're still on vacation, or you maybe got sick from eating too much turkey, here is what we're doing today so you can follow along. Now before I jump in here, what you need from home or to do this lab is you need to make sure that you have this data table. So if you want to pause it and copy this down in your notes, or you want to go to my website and print it off, you can do so. There are 4 columns, and under each heading there are 5 boxes, or 5 rows, I guess. So make sure that you have that, and if you're ready to go, we'll jump right in here. So hot cold pack labs, the whole idea of this is we're trying to determine the difference between an exothermic and endothermic reaction, which shouldn't be a new concept. We talked about this a lot in our chemistry unit towards the end there. And you saw an exothermic reaction, or I guess experienced one, when you felt the test tube during the hydrochloric acid and zinc reaction. It became hot. This is an exothermic reaction. Here's what that means. I'm just going to read this to you. You can also read it yourself. But basically, every reaction requires energy. So to get started, it needs energy to get it started. So every reaction requires energy to get started and gives off some energy as the products are formed. Often, this energy takes the form of heat. If more energy is given off when the products are formed than what was required to start the reaction will feel hot to the touch. We call this exothermic reaction, okay, or exiting heat. Burning a piece of paper is an example of an exothermic reaction. You must provide some initial energy in the form of the match to get the reaction going, but in the end, more energy is given off than it took to actually get the reaction going. So it's exothermic. More heat exits the reaction as a result. If more energy is required to get the reaction going than is given off when the products are formed, the reaction will feel cold to the touch. This is an endothermic reaction. The reason that it feels cold is that the reaction is taking more energy from the environment around it. Okay, it's pulling in more energy. So it's absorbing it. So when you touch it, it feels cold. So feel like you can remember that. I am asking you to memorize what the difference is between an exothermic reaction and an endothermic reaction. So if you're not ready to do that, pause and kind of let that sink into your brain a little bit, or reread this over again. If you got it, let's move on. So, questions we're exploring in our lab today are which chemical, when combined, or chemicals, I guess, which chemicals, when combined, will produce the best exothermic reaction? And which chemicals, when combined, will produce the best endothermic reaction? So you probably already guessed what we're doing. You're going to be mixing different chemicals to see if it gets hot or if it gets cold. If it gets hot, it is an exothermic reaction. If it gets cold, endothermic reaction means heat's getting absorbed. So I'm not going to tell you what these chemicals are just yet. You're going to experience those in your lab when you get to your procedure. But basically, you'll be mixing various chemicals with water to see what type of reaction is produced, an exothermic reaction or an endothermic reaction. These materials, along with the procedure, are at your lab station, which, if you're watching this by video, will take you to a lab station in just a moment. Your job throughout all of this is to take observations in that chart that I asked you to copy down or print. As you follow the procedure, you're taking those observations. Okay, that way you can conclusively say if it is an exothermic reaction or an endothermic reaction. Now, unfortunately, on the video, you don't have the luxury of reaching out and touching the hot and cold packs or the Ziploc baggies, which are containing the reaction. Okay, but you can be listening to what they're saying, writing those things down too. Okay. All right, let's get started.
Well, first thing I'm going to do is take the baseline temperature of this tap water. Stick it in. And in Celsius, it's 23.7 degrees Celsius.
Great. So if they are taking notes at home, they should write that in their chart right now, right?
Yeah.
Great. All right, everybody, write it in your chart. Go get.
Calcium chloride.
All right, let's go.
7th, 8th, and 9th hour.
Prep room.
Take this.
Hey guys, oh, I forgot to bring a bag.
Here's everybody. Oh.
Just
You go.
baking soda. Oh, that's so just kind of like this. Hey,
Awesome.
calcium chloride. Use it in the back.
Oh yeah, definitely.
We gotta close it first. It's turning white. Oh, it's warm.
Is it really?
Who say that again?
It's warm. It's like excellent one.
Okay. Cool.
Yeah.
And the last thing we need you guys to do is just, it gets really warm, doesn't it? Kind of nice. Is take a temperature and calculate the difference.
The original so it increased 19. The water increased by
39. Oh,
Oh my goodness. It's still going.
it's getting
Oh.
intense. Oh my god.
All right, so I can go with the temperature.
It's for the qualitative observations. It's warm and it has like a light to it, and it's like water, like it's dissolved. The calcium is dissolved in the water.
So then we took our temperature for the warm water and subtracted our original temperature to get 26.3 Celsius.
Great. So I'll let you at home decide if that's an exothermic or endothermic. So now we're with the next group here who tested baking soda. What did you guys figure out?
Okay, so when we mixed baking soda and water, we found that the water turned cold and white, and the temperature of the water was, what was it? I don't have it written down.
Go to Lily's.
20.7 degrees Celsius.
And we said that that is an endothermic reaction because it is pulling the energy out of the air around it.
Okay, cool. So when you measured it, it was 20.7 degrees. Was that it decreased by 20.7 degrees?
No, that was just like the degrees.
Okay, so what did your temperature start at? All right, Lily's going to share calculations.
The water was 23.9 degrees Celsius and it dropped by 3 degrees.
It dropped by 3 degrees baking soda, so therefore that's why you say it's endothermic. So would one of you guys mind sharing what you've done so far for this
and
one?
then we poured water.
So these were what chemicals?
Baking soda and then calcium chloride.
Okay, baking soda, calcium chloride, and water, right?
Yep.
Which one is this one?
The third one. Qualitative. Nope, no, not yet.
And what was your starting temperature for the water, guys?
22.7 degrees Celsius.
22.7 degrees Celsius. So say that again, touch it and tell me what you observe.
It's cold.
It's cold, so it's getting colder.
Fizzling.
Yeah, let's figure that out.
That's 2.1.
And what's the temperature difference?
A 2.1 decrease.
2.1 degree decrease. So this right here is your decrease? Interesting. Okay. Okay, so Mallory and Samantha right now are mixing water and what chemical did you just put in there?
Potassium chloride.
Potassium chloride. Okay, and you guys noticed what happened to the temperature?
It dropped.
It dropped.
Dropped a
Okay.
lot.
Let's figure out exactly how much. Can you measure each in Celsius? This is your baseline temp, right?
Baseline temp is
21.6 or 1.7.
Sounds good. 21.7 degrees Celsius. All right, let's check the bag. Oh, yeah, it's going down.
Going down very quickly.
Did you guys notice when you did this, it felt cold immediately, or did it take a while to get cold?
It's pretty soon after.
Cool. All right, so Samantha calculated that it went from 21.7 to 16.7. That should be some easy math,
And
right?
that comes down to 5 degrees Celsius drop exactly.
Great. Thank you very much. Thanks, guys. Give us a thumbs up. Okay, so there you have it. Long day of testing different chemicals to see if an endothermic or exothermic reaction has occurred. What you need to bring tomorrow is your data that you took today in lab or at home. We'll use that to drive our discussion tomorrow when we talk about constructing an explanation based off of evidence with claim evidence and everybody's favorite, reasoning. Have a great rest of your night, and we will see you tomorrow.